Pre-Calc, and welcome back. We are going to be finishing up the 2-1 day 1 notes. We did the front side already, and so now we're going to be going on to the back. We're continuing limits. This one we've got the limit as x approaches 0 of tangent of x all over x. For this particular problem, plugging in a 0 to figure out what the limit's approaching would not work because it would make it undefined. So what I'm going to do is I'm going to kind of rewrite things a little bit. This is going to be the same thing as the limit as x approaches 0 of, I'm going to split this up. I'm going to rewrite it as the tangent of x times 1 all over x. All right. And then what I'm going to do is I know that tangent of x can be rewritten in terms of sine and cosine. This will be the same thing as the limit as x approaches 0 of sine of x all over cosine of x. Remember, sine of x over cosine of x equals tangent of x times 1 all over x. All right, and then what I'm going to do is I'm going to kind of swap things around a little bit because if you remember, we talked about this at the very beginning of the notes last time, is this lovely fraction is going to pop up quite a bit. The limit as x approaches 0 of sine of x over x equals 1. So if we could get this to look like, if we could get our problem to have a sine of x over x, we know that that portion is going to equal 1. So we can get that actually in this problem. I'm going to swap denominators. This is going to be the same thing as the limit as x approaches 0 of sine of x over x times 1 all over cosine of x. All right, just kind of swap the denominators. And then what's going to happen is once you have it split up, what you can do is you can take the limit of each piece, find out what they both approach, and then because these are being multiplied together, we'll multiply our answers together, and that will give us our final answer. Okay, so what we can do is we can find out what the limit as x approaches 0 of sine of x over x is. And we're going to find out what the limit as x approaches 0 of 1 all over cosine of x is. Once we know those two limits, we're going to multiply them together. Well, the limit as x approaches 0 of sine of x over x, we already talked about that on the front page. That's going to be equal to 1. And then the limit as x approaches 0 of 1 over cosine of x, this one you can actually plug the 0 in. 1 all over cosine of 0. Well, we know what cosine of 0 is. That's 1. So really, we're saying the limit as x approaches 0 of 1 over 1. Well, 1 over 1, that's just 1. All right, so the limit of the first piece is 1, the limit of the second piece is 1, and then we multiply them together. 1 times 1, you're going to get 1 for your final answer. Okay, so if you can't find the limit of this original problem, you can always kind of split it up into a multiplication problem and then find the limit of each piece and then multiply those pieces together. Okay, we're going to find the limit graphically and then confirm algebraically. I'm not even going to do it graphically. I mean, you certainly can graph it. I'm just going to do it algebraically. One or the other is totally fine. So what we're going to do is we're going to find the limit as x approaches 0 of this thing. And if you plug in 0, obviously it's going to make it undefined. That's not going to work. So what I'm going to do is I'm going to split it up. This is going to be the same thing as the limit as x approaches 0 of, I'm going to put the first piece over x, so 2x over x, and then plus sine of x over x. Right, so if you combine those together, you will get the original. And then what we're going to do is we're going to take the limit of each piece. So the limit as x approaches 0 of 2x over x. And we're going to do the limit as x approaches 0 of sine of x over x. Okay. Well, if you look at this piece here, the x's are going to cancel. So really you have the limit as x approaches 0 of 2 plus the limit as x approaches 0 of sine of x over x. The limit as x approaches 0 of 2, again, it's just like a horizontal line. As you approach 0, the y values, they're staying at 2. So this is going to be 2. And then we already know this one. All right, the limit as x approaches 0 of sine of x over x. That's just something you should have memorized. That's going to be 1. And then you add them together. All right, and the answer is going to end up being 3. All right, so the limit as x approaches 0 of 2x plus sine x over x is going to end up equaling 3. So you can kind of take something that looks really tricky and kind of weird, and split it up and maybe make it smaller and easier to work with. All right, we're going to deal with right-hand limits versus left-hand limits. Okay, right-hand limits are going to be what the limit of f of x as x approaches from the right, and the left-hand limit is going to be the limit of f of x as x approaches a value from the left, right? If the left-hand limit does not equal the right-hand limit, RHL is right-hand limit, LHL is left-hand limit, if they don't end up equaling each other, then we would say that the limit does not exist, DNE. So let me give you an example so that this makes sense. All right, so let's say that we wanted to find the limit as x approaches 2, and we have like a little plus sign here. The plus sign means from the right side, from the positive side. Okay, now this graph is, remember, int x, the greatest integer less than or equal to this value. So we're going to put int x, right? So for the limit, as x approaches 2 from the right side. So here's where 2 is, obviously. All right, from the right-hand side, all right, so from here on the right-hand side, not the left hand, but the right hand. From the right-hand side, as we get closer and closer to where x equals 2, you can see that the y value here is 2. All right, it's staying the horizontal line segment, and it's going to stay at a y value of 2. So this thing is going to equal 2. If we look at the limit from the left, so the limit as x approaches 2 from the left side. So as we get closer and closer to 2 from the left side, so that means we're dealing with this segment here, right, this piece. As we approach 2 from the left side, all right, it's staying at a y value of 1. All right, so my y value is going to be 1. Right? As we approach 2 from the left side, the y value is 1. If we do the limit as x approaches 2 without the left hand or the right hand, right? So this means the limit as x approaches 2. Right? In order for the limit to exist, whatever you're approaching from the left should be the same as what you're approaching from the right. If you notice, what we approached from the right was different than what we were approaching from the left. Since the left-hand limit and the right-hand limit are not equal, we would say that this answer does not exist, DNE, right? The left-hand limit has to equal the right-hand limit in order for the limit to exist. Now, if you were to just find f of 2, not a limit at all, but just f of 2, if you look at where 2 is, all right, and you were to actually go, let me erase some of this because this is kind of overlapping the picture a little bit. If you were to go to f of 2, all right, there's an open circle at 2 and a closed circle at 2. F of 2 means you're going to go to where it is equal to 2. So this it's not equal to because it's open. It would have a y value here at 2. So f of 2 is 2. All right, so it's a little bit different depending on what you're looking for. F of 2 itself is 2. The limit as you approach 2 from the right will be 2. The limit as you approach 2 from the left is actually 1. And then the limit as x approaches 2 does not exist because the left-hand limit does not equal the right-hand limit. Okay? We got 2 more problems down here at the bottom. So we're going to graph and find the following. So you are going to need to remember some of your graphing skills. This is a piecewise. So as x is greater than or equal to 0. Okay, so it's equal to 0 and anything bigger. So if we plug in 0, we're going to get 2. If we plug in 1, we're going to get 3. If we plug in 2, we're going to get 4, etc. So my graph is going to look like this. This one, less than 0. So at 0, it's undefined, or there's a hole. So if we plug in 0, we're going to get negative 1. So 0, negative 1, there's a hole. Less than 1, so we want to plug in like negative 1. Opposite of negative 1 is 1. 1 minus 1 is 0. Oops. 0 right there. If we plug in negative 2, all right, 2 minus 1 would be 1. So if you plug in negative 2, you get positive 1. So the graph's going to look something like this. Right? Once you have it graphed, then you can answer the questions. The limit as x approaches 0 from the right. All right, so what we're going to be doing is we're going to be approaching 0 from the right-hand side. So from the right-hand side, we're going to use this piece of the graph because that's on the right. This one's on the left. As we approach 0, it means we're kind of going down this line. As we approach 0, we're getting closer and closer to a y value of 2. So the answer is going to be 2. Now, the limit as x approaches 0 from the left side. That's going to be this piece. As we approach 0 from the left, we're getting closer and closer to that hole. That hole has a y value of -1, right? We're not actually saying at the hole. It's just we're getting closer and closer to a y value of -1. The limit as x approaches 0. Right, notice this one does not have a right hand or a left hand. In order for the limit to exist, the limit from the left side should approach the same thing as the limit from the right side. Notice these are different. The left hand limit equals -1, the right hand limit equals 2. Since these are different, my limit is going to be does not exist. F of 0 itself, all right, that just means what is, oops, I didn't mean to erase the whole thing. What is our y value at 0? All right, at an x value of 0. Well, we're going to go to where the closed circle is at 0, and we have a closed circle here at 0, 2. So 2 would be f of 0. And then we're going to use the graph to find the following. So let me give you the graph. Let's say at 1 here you have a closed circle, and the line's kind of going down like this. And then let's say down here at -1 you have an open circle, and the line's kind of going up like this. All right, so there's our graph. We're going to answer some questions. So the limit as x approaches 0 from the right-hand side. So we're going to be dealing with this branch here. As we approach 0, as we get closer and closer to 0, what are the y's approaching? Well, the y's are approaching this hole at -1. So the y value is going to be -1. The limit as x approaches 0 from the left side. That's going to be this left piece. As we approach 0 from the left side, we're getting closer and closer to this point here, which has a y value of +1. So then when we try and find the limit as x approaches 0, this time you'll notice again, the left-hand limit and the right-hand limit are different values. Since the left-hand limit does not equal the right-hand limit, the limit as x approaches 0 is going to be does not exist. Right? If these two values were equal, then the limit would be whatever those values were. F of 0 itself, you're going to go to where you have a closed circle. F of 0 is right here at 1. All right, so that is limits, and we'll do more of those tomorrow. Thanks for listening.